Good morning, everyone. Welcome to the class of C333 Environmental Engineering 2. So, the title of this course is Wastewater Engineering and Sanitation. Wastewater Engineering and Sanitation. So, here, basically, we are trying to deal with the wastewater. First of all, why we need to deal with the wastewater? You know, wastewater, that means polluted water, right? That means it has pollutant. So if this wastewater comes into contact with a person, then it might be deleterious to the health of this person. That means wastewater pose a risk to the health of human being, right?
Yes, sir.
So wastewater can transmit disease. So we need to stop this transmission of the disease. That means we need to stop the wastewater being in contact to the human being. That means we need to safely discharge it into the environment. If we directly discharge this wastewater into a river, then river is gonna be polluted. The fish and other aquatic life will be in danger. And you know that river directly affects the life of human being. If river is polluted, then polluted river will also generate disease or cause disease. If the wastewater contains um, heavy metal, right, heavy metal, then fish will consume it, and the heavy metal will go into the flesh of the fish. And if people eat this fish, then heavy metal will also accumulate in the body of the people, and eventually it may cause cancer and other fatal diseases. So that's also sanitation. Sanitation means what? Sanitation means protecting the human health by um, basically managing the wastewater. Okay, that means you are stopping the transmission of the disease to the human body. Clear?
Yes, sir.
So basically, wastewater and sanitation. We are dealing with this in this chapter. Now, look at this example. We supply fresh water to a building, fresh water, right? Now, you use it for many purposes, like in a wash basin, in the toilet, in a bathroom, in your kitchen. And once you use the water, then it becomes what? Wastewater. Once you use this water, it becomes wastewater. Let's designate it in by red color. So that's wastewater. So that means you need to discharge this wastewater safely as soon as possible, right? And therefore, we need to transmit the wastewater, transmit from the generation, from the source of the generation to somewhere else, and treat it, treatment. That is removing the pollutants, and then safely discharge it into the river. Did I make it clear?
Yes, sir.
Yes, sir.
Okay. Now, for example, the BOD here, you know what is BOD by now. So BOD here is it's a still I'm telling repeating, BOD actually represents the amount of organic matter that's present in the water. So, for example, BOD in this water is 50 milligram per liter by the Bangladesh Environmental Conservation Rule (ECR), right? Tells you that the maximum limit of BOD of water to discharge into the river, that is around 5 to 6 or something like that. Okay. 5 milligram per liter. That is, can you directly discharge this water into the river? Can you directly discharge this water into the river?
No, sir.
Maximum 5 to 6. You have 50. That means you need to treat this water from 50. You have to reduce it to 5 and 6, and then you can discharge it into the river. Clear?
Yes, sir.
So you have to know these rules and regulations from Environmental Conservation Rule (ECR). Okay, and accordingly you have to design this wastewater treatment plant. That means uh, the thing is you have to design wastewater treatment plant. You have to design it. Okay, we learn this in this course, and you also need to learn how to transfer this wastewater to from the from the source of generation to some other place. So how do we do this? We do this using a pipe, right? We do this using a pipe. So this pipe which contains the wastewater, the pipe which contains the wastewater, that's called what, guys? That's called sewer. Remember this terminology, sewer. SEWER. Clear?
Yes, sir.
Which
Yes, sir.
the sewer is a pipe. Remember, sewer is a pipe which contains the waste water, which transfers or transmits the wastewater. Now, this wastewater, this is called sewage. SEWAGE. So sewage is the wastewater, and sewer is the pipe which contains or transmits the sewage. Did I make it clear?
Yes, sir.
Okay. So together, this sewer and this sewage together, this system is called sewerage. Together, this system is called sewerage. Clear?
Yes, sir.
Okay. So this is the course content. We'll learn these things. Inshallah. I already told you the references. Okay. Uh, we'll start from here. Yeah, start from here. Sanitation. As I was telling you, that sanitation. What is sanitation? Uh, this is the world's most urgent issues. One of the world's most urgent issue is what? Issue is what? Lack of safe water, sanitation, and health. Okay, if you want to develop a country, then you need to um, meet the water demand because it's related to child mortality. Okay, and it's related to the development of human being directly. So here comes the role of sanitation. Sanitation is defined as the access to and use of facilities and services for the safe disposal of human waste. Safe disposal of human waste so that this waste cannot harm human. So you need to safely dispose it. That is sanitation. Did I make it clear?
Yes, sir.
So according to the World Health Organization, sanitation refers all conditions that affect health, including control of water supply, excreta, human waste, human solid waste actually, excreta, wastewater disposal, refuse disposal, housing condition, food protection, atmospheric condition, and the safety of the working environment. So these are all part of sanitation that affect health. Okay. Did you hear the name wash? This is water. WA
Yes,
means
sir.
water. S means sanitation, and H means hygiene. Wash. Okay. So I already discussed it with you previously. Remember this terminologies. You may need this while you are going for job interview or test and exams. So SDGs, Sustainable Development Goals of the UNDP. Um, Goal number 6. It has total 17 goals. Goal number 6 is directly related to the WASH. That means water, sanitation, and hygiene. So access to water, sanitation, and hygiene, collectively known as WASH. WASH has profound, wider socio-economic impacts, particularly for human, women, and girls. Okay. So, what is the motivation of sanitation? Because sanitation has profound impact on the socio-economic aspects of a country. If you want to generate money, if you want to develop a country, then you need to protect the health of the human being. And without sanitation, you cannot do this. That's why you need to invest money on sanitation. If you invest money on sanitation, then you will get more in return. Clear?
Yes, sir.
So to meet the demand of sanitation, you need to have wastewater engineering. So in this wastewater engineering, we will have we will need to learn some terminologies. First of all, domestic sewage. I already told you sewage is the wastewater. Domestic means it is generating from the household. So domestic sewage or sanitary sewage is the liquid waste which originates in the sanitary conveniences, water closet, that means commode, we call it urinals, bath, sinks, etc. Of dwelling, that means residence house, commercial or industrial facilities and institutions. This is sometimes also referred to as black water. Clear?
Yes, sir.
So sanitary sewage, industrial sewage or industrial wastewater includes the liquid discharge from the from spent water in different industrial processes like manufacturing and food processing. For example, you have a textile industry. You have a textile industry. You are taking fresh water and you are doing processing here, leather processing, textile industry, leather processing, and the tannery industry. So you have tannery industry. You are processing the water. You're processing the leather. Sorry, with the water. So after processing, the water is wastewater. This is wastewater. So this is an industrial wastewater. And this can be leather industry, that can be tannery industry, that can be textile industry. Okay, so these are basically industrial wastewater. From the household, if the wastewater is generating from a household or a bank or a school, right, or office, then this is sanitary sewage. Clear?
Yes, sir.
Sewage is what, you know, in household sewage, I mean sanitary sewage, uh, some wastewater is generating from the toilet and some wastewater is generating from the kitchen. So the wastewater that is generating from the kitchen, that is not as much as pollutant from the wastewater that is generating from the toilet. Am I right?
Right, sir.
Yes, sir.
So this is less polluted. This is called sewage, less polluted. Okay. Liquid discharges from the kitchens, wash basins, etc., and exclude discharges from water closet, that means commode, urinals, etc. Sewage is also known as grey water, is less foul. Less foul means less polluted than domestic sewage and can be discharged through open surface or drains in unsewered areas since they are less polluted. Then storm water. For example, you have a community here. You have a community. Uh, call it. This is a watershed. High elevation, lower elevation. Okay. So how does the watershed look like? Looks like this, right? So you have a building here, there, there, right? And whenever there is precipitation, rainfall and snowfall precipitation, okay, what happens? This rainwater will transfer from higher elevation to the lower elevation. Am I right?
Yes, sir.
From higher elevation to lower, higher elevation to lower elevation, higher elevation to lower elevation, higher elevation to lower elevation. So basically, these are storm water. Okay. Now remember, it's also important to discharge this wastewater. I sorry, the storm water uh, as soon as possible. Otherwise, what would happen? Tell me. Otherwise, what would happen?
Sir, flood.
Flooding. Otherwise, there will be flooding. Flood. Right?
Yes, sir.
Sewer, I already told you, this is a pipe or conduit. Okay. Infiltration is the water which enters the sewers from the ground through leaks or faulty joints. That means, look, this is the sewer, right? Let me tell you, show you another figure that shows it. Or this is a sewer, right? This is a sewer, and the this sewer is coming from this house, collecting the wastewater from this house, and then you have another house here. That house is also discharging to another pipe, right? To this larger pipe, to this larger pipe. Okay, so this pipe, this larger pipe, is for the sanitary wastewater. So that's called sanitary sphere. Okay, and this pipe, as you can see, blue color, that's basically collecting the storm water. So this is a storm sewer. Clear?
Yes, sir.
You are not mixing them. You are not mixing them. You are using two separate pipes or sewers to collect sanitary sewage, and storm sewage. Sometimes you may also combine them together. Sometimes you may also combine them together. That means one single pipe that will collect or transfer both sanitary and storm sewage. Anyway, now look at this pipe. This pipe has some crack. This pipe, maybe this is 20 or 30 years old. That's why, due to aging, it has many cracks here. Okay, it has many crack, leak. So what would happen if there is rainfall? The rainwater will infiltrate through this leaky portion. Am I right?
Yes, sir.
That's called infiltration. That's called infiltration. Infiltration. Okay. Sanitary sewer, I already told you what is that. Storm sewer, I already told you. Sewerage, that refers to the entire system of collection, treatment, and disposal of sewage through a system of network of sewers. So the essential elements of a sewerage system is collection and conveyance. That means, uh, first of all, you need to collect the wastewater through pipe, here, this pipe, right? And then you need to transfer them to somewhere else, right? And then you need to treat that sewage in a wastewater treatment plant. These are the primary function of a sewerage system: collection and conveyance, treatment, and then finally disposal. After treatment, you have to dispose the um, treated water safely. The typical figure of a of a sewerage system, as you can see, this is a sanitary sewer. Roof drain, that means the water that's falling in on the roof, that is being collected through this gutter, and then finally discharged into the, where, into the storm sewer, to the storm sewer. And the wastewater that's coming from the toilet and the other area, that is discharging into the sanitary sewer. Clear?
Yes, sir.
Okay. and the rainwater that is falling here, that will be collected through this manhole in the storm sewer, right? Sometimes
Yes.
in the foundation areas, you may have water seeping, so you are also collecting it and discharging it into the storm sewer. Conventional sewage system, basic functional element. Uh, I already told you these things. Types of collection systems. Separate sewerage system. Separate sewerage system means, as you can see, you have a separate sewer for sanitary wastewater and storm wastewater. So this is a separate sewage system. Separate sewage system. In this system, two separate drainage systems exist in parallel. One is sanitary sewer system and the other is storm sewer system. Sanitary sewer system collects the wastewater and discharges it to a treatment plant. And storm sewer, this is not that much pollutant. This is not that much pollutant. Therefore, this is directly discharged to receiving water. That means river, canals. Okay. Advantage and disadvantage. Spheres are of a smaller size since you have two separate sewage systems. So the pipe diameter can be smaller. Only sanitary sewage is treated. That means you need to treat only the sanitary sewage. You don't need to treat this storm sewage. Storm water can be discharged without treatment. That's what I was telling. Sewage lifting is less costly because of less volume. For the disadvantage, two sets of sewers may prove costly. That means here you have to lay out or construct two separate sewers, which might be costly installation. And smaller sewers may be difficult to clean. If you have two separate sewers, as I told you, diameter will be smaller, but a smaller sewer is difficult to clean. Remember, this sewage contains liquid and solid, right? So this solid may get deposited sometimes here and create blockage. So you need to clean it regularly through the manhole. Did I make it clear?
Yes, sir.
Yes.
Okay. Now combined sewerage system. In combined sewerage system, you will have only one pipe, bigger pipe basically, this, which is so all the wastewater from sanitary as well as the storm water will be discharged into this bigger single pipe that is combined. That means you have combined them together. You should go this advantage and disadvantages. Partially combined or partially separate system. What's that? So it has the property of both one and two. So in this system, only one set of sewers is laid to carry sanitary sewage as well as stormwater during low rainfall. During heavy rainfall, excess stormwater is carried separately through open drains to natural drains. That means you have this sewer, okay? Um, in dry season, that means in winter period, you will have less rainfall. So at the pipe here, this is the ground surface. Okay? The pipe is under the ground. So in dry season, that means winter, rainfall is in a small amount. So the wastewater and the stormwater level will be here, right? Or maybe here. But when there is a rainy season, then of course the rainwater will be much higher, stormwater basically. And as a result, this will the water will overflow. The water will overflow, and the excess water will be transferred through open drain. Did I make it clear?
Yes, sir.
Yes, sir.
You will have system here that can transfer the excess rainwater or stormwater. Okay. Suitable condition for separate system. In which condition you will give separate system? In flat areas like Bangladesh basically. I mean Dhaka, Rajshahi, right? And not hilly areas like Sylhet or Chittagong. In flat areas, a separate system is economical as deep excavations are not required. In flat areas, you don't need deep excavation, right? When sufficient funds are not available for two sets of, I mean, yeah, suitable condition for a separate system, okay? When sufficient funds are not available for two sets of sewer system, then only one sanitary sewer system may be installed. Where rainfall is not uniform throughout the year, a separate system is suitable. Okay. In rocky areas where large combined system may be difficult to install. Okay. And if sewers are to be laid before actual development of the area, a separate system is desirable. Okay. Suitable conditions for combined system. Where rainfall is uniform throughout the year and a combined system is economical. Where pumping is required for both sanitary sewage and stormwater. Where sufficient space is not available for two sets of sanitary systems. Now, types of sewers. Types of sewers. This is important to know. The types and size of sewers vary with size of collection systems and the location of the wastewater treatment facilities. The principal types of sewers found in most collection systems are as follows, like building sewer and lateral or branch sewers. What is building sewer? Also called house connections, used to convey wastewater from the building from the building to the lateral or branch sewer. Normally begin outside the building foundation. I'll show you the picture, then it will be clear. What is lateral sewer? Lateral sewers form the first element of a community sewage collection system and are usually in streets. They are used to collect sewage from one or more building sewers and convey it to the main sewer. Let's look at this now. What is building sewer? What is main sewer? Look at this. This, are you following me, guys?
Yes, sir.
So this
Yes,
pipe
sir.
is collecting the wastewater from the building or house. Okay, so basically this is the building sewer. This is the buildings here. This here, this is the building sphere. This one. As I told you, another building here is discharging through this pipe or sphere. So this is a building sphere again. So multiple building spheres like this and this is discharging into this lateral sphere. This is the lateral sphere. Did I make it clear?
Yes, sir.
Yes, sir.
Or branch sphere. So building sphere discharges where? To the lateral sphere. Right? And there is this building, is the building sphere. The building sphere. Now look, let's look from the top. Let's look from the top. So basically you're looking at the plan view. This is a building. This is another building. This is a building. This is another building. Are you following me, guys?
Yes, sir.
Yes, sir.
So this building is discharging through buildings here. This building is discharging through another building here. This building is discharging through these buildings here. This building is discharging through this building here. Clear?
Yes, sir.
There is another building. This is a building here. This is a building here. Multiple buildings, multiple building spheres like this one, this one, this one, and this one are discharging where? To this lateral sphere. So this is the lateral sphere. Alright? Alright?
Yes, sir.
The lateral sphere. Let's say this is higher elevation, this is lower elevation. So if this is a gravity system, then the water will flow from higher to lower elevation in this direction, right? Similarly, this is another lateral sphere. Lateral sphere, lateral sphere. This lateral sphere is also discharging in this direction. Are you following me?
Yes, sir.
This is another lateral sphere. This is discharging from higher to lower elevation. This is another lateral sphere. Discharging elevation from higher to lower elevation. Now, all these lateral spheres, this one, this one, this one, this one, they are discharging to where? they are discharging to another pipe that's called main sphere. The pink color that you are looking here, that is the main sphere. That is another main sphere. Okay. This is a main sphere. These laterals were this one, this one, this one. They are discharging into relatively bigger pipe. That is called main sphere. Clear?
Yes, sir.
As you can see, similarly, this one is a main sphere. Main sphere. This one are lateral sphere. Now, this main sphere, this main sphere, they are discharging into another pipe, bigger pipe. That is called trunk sphere. That's called trunk sphere. So these main spheres, this one, and this main sphere is discharging into this another bigger size pipe that is called trunk sphere. Clear?
Yes, sir.
Trunk sphere. And finally, by the way, there is another trunk sphere. This is another trunk sphere. This is another trunk sphere. Okay. This is a main sphere. The main sphere. This is a main sphere. This is a main sphere. Okay. And these are basically the lateral spheres.
স্যার কথা অনেক আস্তে আসতেছে।
These are basically the lateral spheres. Okay. Now, what we have seen so far is that from building sphere to where, guys? From building sphere to where? You tell me now. From building sphere, the blue one, to what? From building sphere to where?
Lateral sphere.
Lateral sphere. From lateral sphere to where?
The main.
Sphere. Main sphere. From main sphere to
Trunk.
trunk sphere. From trunk sphere to, that is called intercepting sphere. Final one, the intercepting sphere. And this intersecting sphere finally, uh, as you can see, it collects the water from this lateral trunk sphere, this trunk sphere, this trunk sphere, Okay, and finally is discharge the wastewater to the water treatment plant. Okay, the black one. Now, usually we make this gravity flow, so higher to lower elevation. Okay, and this pipe sometimes may need to may be maintained, like cleaning and other purpose. So this always remember that this pipe system is under the ground. Am I right?
Yes, sir.
So this pipe system or pipe layout must not be under any building. Otherwise, if there is a building, then if there is a blockage here, can you maintain this pipe? No, you cannot access the pipe. Can you destroy or break this building to maintain this pipe? No, that's not possible. So you have to remember that your pipe layout must not be under any important structure or any building. Did I make it clear?
Yes, sir.
Yes, sir.
That means your pipe system must follow the road network. The road network. That means if I show you here, look at this. This is the building, right? This is another building. Another building. Can you see this?
Yes, sir.
Does it allow me to write it here? Okay, that's okay, no problem. I can show it from here. So your pipe layout should follow the road network. That means this is the road, right? This is the road. So your pipe network should follow this road layout like this. You cannot lay out your pipe here. Here. I call it.
স্যার কথাটা শোনা যাচ্ছে না স্যার।
So what I'm trying to say here. Look at this. This is the road, right?
Yes, sir.
This is another road. These are buildings. So your pipe layout should follow this road network. And then bigger road. Okay. You cannot lay out your pipe under the building. Can you do that? Okay. You cannot lay out your pipe under the building. You have to follow the road network. They make it clear.
Yes, sir.
Okay. We have learned these things. It's the same thing. And in these junctions, like here, junctions. Here is a junction. Here is a junction. Here is a junction, right? In these junctions are susceptible for clogging because this is getting the flow from different directions. That's why you may need to clean these cloggings on a regular basis. That's why you need to keep provision for cleaning. That means manhole. This is the junction I was talking about. Okay, like this is the lateral sphere. This is the main. Okay, and this is the manhole. So ground surface is here, maybe 6 feet above. So you should keep provision so that a person or a robot can go there and clean the cloggings or blockage. Clear?
Yes, sir.
And now you know what's main sphere, trunk sphere, intercepting spheres. Engineered sanitary sphere overflow. Sometimes, yes,
Intercepted is a final sphere.
yeah, that basically convey the wastewater to the treatment plant and other disposal facility. Um, Sanitary sphere overflow. What's that? If for example you have designed this sphere for maximum 10 meter cube per second. Okay. Now, if your real flow is 11 meter cube per second, then this pipe will not be able to make or meet the demand. In that case, the water will overflow in the street to the manhole. Am I right? And that
Yes, sir.
wastewater will then go into the roadside network and then may go to the river, pond, and eventually will pollute the environment, posing risk to the human and other aquatic life. So, heavy rains sometimes may do this, overload the system through inflow and infiltration into cracks, ill-fit joints, and leaky manholes. This is quite frequent in Dhaka, Chittagong, Mumbai, and other cities. To prevent this overload of treatment plants, the excessive sewage bypass the plant is discharged without treatment. It's not a good option though, but sometimes you have to do this. And because of this pollution, nutrients and toxicants may cause algal bloom and harm wildlife and aquatic life, as I told you. Decrease in water quality reduces number and ranges of plants and fish, and public health is also hampered because direct contact with water containing sewage can cause skin and other diseases. Okay, any questions, guys? Any question?
No, sir.
Okay, so that's all for today. If you don't have any questions, then thank you very much. Have a good one. Stay safe.